pause on that and you can come back to it later. Does that sound good? Okay. We're on page 77. Okay. So we have oleic acid is one of the main fats in olive oil. A molecule of oleic acid has a mass of 4.692 times 10 to the negative 22 grams. What is the molar mass of the oleic acid? Now, normally, when you want to find a molar mass, what have you been doing up till this point before yesterday? You've been looking on the periodic table. Will you find anything about oleic acid on the periodic table? There is no such thing on the periodic table. So that means that this is an unknown substance. We don't know its formula. So we need to use what we know about molar mass. What is molar mass equal to? What are the units? Grams over moles. You're responsible for knowing that. If you don't know that, you won't be able to solve this kind of question. Okay? Now, in the question, we should be giving you grams, and we should be giving you moles, or some way of finding those things. Yes? Are we given the grams in the question? Yes. We have it right there. So let's go and pop that into our equation. We have 4.692 times 10 to the negative 22 grams. Are we given moles in the question? No. I would like you to take a look at the question and see if there's anything else given there that we could use to figure out moles. Yeah, we have one molecule. If you're like, how did they figure that out? Well, if you read your first sentence, oleic acid is one of the main fats in olive oil. Is there any useful information in there? Well, olive oil, yum, but you know, not really. And this mass, we've already used the mass. We are finding the molar mass. The only thing left here basically is this molecule. And if we say a molecule, what do we mean? We mean one molecule. Yes? Are we able to convert one molecule into moles? Molecules and moles, can we convert between molecules and moles? What conversion factor do we use to go back and forth between molecules and moles? We use Avogadro's number, yes, Avogadro's number. So let us convert molecules into moles. So let's cancel the molecules and find the moles. Tell your partner where the 6.02 times 10 to the 23 goes. Does it go on the top or does it go on the bottom? Tell your partner. Where does the 6.02 times 10 to the 23 go? On the top or on the bottom? It has to go on the bottom because the 1 goes with the mole. Besides which, there's lots of molecules in 1 mole of molecules, right? So that makes some kind of sense. So we do that, and when we do the division, we get 1 divided by 6.02e23 equals 1.66113 times 10 to the negative 24 moles. So now I can take this number of moles, and I can put it up into my formula right here. Yes, I'm going to take that number and put it into the grams over moles. So I'm going to put in 1.66113 times 10 to the negative 24 moles times 4.692 times 10 to the negative 22, and we get 282.4584. How many significant figures should we have in our answer? We've got a 1 here. How many sig figs? Infinite. We got a 1 here. Infinite. We got a 6.02. 3 sig figs. We got a 4.692. 4 sig figs. So we need to have 3 sig figs. So that's then going to become 2.82, not 2.82, 282. And what is the unit? Grams per mole. Okay, so that's just a quick review of what we did last day, plus that little one molecule thing. If you see a molecule, it means one molecule. Okay, let's go to dilutions 2 now, the one you just picked up from the front. If you didn't pick it up, it is on the corner of the desk here. If you are not taking Chemistry 12, then you can just go and practice. Either if you didn't do well on the quiz, you can go and do some of 5.2F, or you can do some of this stuff from last day if you didn't do it, or you can go do any of 5.3C. You could do 5.3C. That's going to be on Monday's quiz. Okay, so if you're not doing it, you can do 5.3C. We've already done some of them. You can do the rest of it. Okay. So if you're just hanging about waiting for us, that will be a good thing to work on. Or you can study for the re-quiz if you need a re-quiz. Thank you so much. Okay, often in a lab storeroom, we have these things called stock solutions. And a stock solution is a solution that has a fairly high concentration. And the reason we have this is we don't always want to be mucking about with the solid, like today, measuring out the amount. Sometimes the actual grams would be so small, it would be actually hard to weigh it out. So sometimes what it's nice is to have a solution of a high concentration that we can then easily dilute to get a lower concentration. Okay? So for example, you might have 10 molar hydrochloric acid, and you could dilute it 1 in 10 times to get 1 molar HCl. And if you don't know what it means to dilute something 1 in 10 times, maybe what I might do is I might take 1 liter of HCl and 9 liters of water. That would give me a total of 10 liters. Yeah? And that would be a 1 in 10 dilution. You don't need to know that language. So if you're like, I don't care, you can just not care. Or you can do a 1 in 100 times dilution, and you would get, I'm sorry, this should have just said 0.1, not 0.01. And that might be where you had 1 milliliter of the HCl, 99 milliliters of water, giving you a total of 100 milliliters. Okay, and that would dilute it by a factor of 100. So we went from 1 molar to 0.1 molar. Or sorry, 10 molar to 0.1 molar. Now, if you didn't understand that, that's okay. We're going to just take a look quickly at the procedure for this. It looks a lot like what we did today, except that we will be starting with our stock solution, which is a highly concentrated solution. What do we call the highly concentrated solution? Okay, 3 people answered me. What do we call the highly concentrated solution? The stock solution. What do we call the highly concentrated solution? The stock solution. What's it called? Stock solution. What is a stock solution? Excellent. Okay, so what we do is we take some of that, and we have another empty flask just sitting here waiting, okay? And we transfer that stock solution into our new flask, okay? And then we take the solvent, which is the water, and we add water to the line. Okay? Now the key idea with this, do you guys remember what we could say about the moles before dilution? What's true about the moles before dilution? What happens to them after dilution? My moles of solutes. Solutes, add water. What happened to my moles? They stay the same. So the moles of solute before dilution are equal to the moles of solute after dilution. So over here, this is our final dilute solution. And this is what we want to make. You will be told, I would like you to make 500 milliliters of this dilute solution. I would like the concentration of the dilute solution to be 0.2 molar. So you will know both the volume I want you to make and the concentration I want you to make. So this dilute solution, we know the molarity, the moles per liter, and we also know the volume, liters. Because this is something I'm like, go make me 2 liters of 0.5 molar HCl. You know the molarity, you know the volume. If you know molarity and volume, what can you find? Tell your partner. If you know these two, what can you find? You can find the moles, because liters times moles over liter gives you moles, okay? So if you know these ones, you can find the moles. So what you're actually going to be doing is in your very first step, you're going to find the moles that you need in the final diluted solution. So that's why it says over at the beginning, figure out how many moles are needed in the final dilute solution. Okay, so you're thinking ahead. How many moles am I going to need to get that wanted concentration and volume? Now the question becomes, how much of this original stock solution do I need to get that many moles? Okay, so you're going to say, what volume of that stock solution contains that same number of moles? Because remember, moles before are equal to moles after. And these two steps here, these are going to be the math steps. Okay, that's where you do your calculations. Okay, you find your moles, and then you find your volume. You are going to then measure, now the rest of it's just procedure. You measure out that volume, so let's just take a look at the whole thing. You're going to measure out that volume. You're going to transfer it to the new flask. You're going to dilute it by adding water until you get to the mark, okay? And then you're going to do what we did today, and you're going to fill it to the line and stopper it and invert it to mix it. Okay? So, math steps, and then there's some procedure. All right? Let's walk through the math steps. First thing we want to do is we want to find the what of solute. We want to find the moles of solute. And actually, I'm going to give you a little hint here. Whether it's this worksheet, anything else in the mole, if you don't know what else to do, start by finding moles. Because chances are, it will get you on the right path to where you're going. So if you're stuck and you don't know what else to do, first step, when you're stuck, should be just find the moles. If I give you grams, what could you do with it? Find the moles. If I give you molecules, what could you do with it? Find the moles. If I give you volume and molarity, what could you do? Find the moles. Volume and molarity allow you to find moles. Okay? So, find the moles of the solute you need in the final dilute solution. So you're actually kind of working backwards. You're saying, how much do I need at the end? And then you're going to use those moles to figure out what volume of the stock solution contains that many moles, and that's how much you're going to use in your dilution. So we're going to do a little visual, and then we'll do it mathematically. If you don't like the visual, that's okay. I'm not sure how I feel about the visual. Half of me thinks it's great, half of me is like, I find it's just maybe confusing. I don't know. So we want to make 2 liters of, I'm using these little dots again, concentration of dots 2 molar. That's what we want to make. Is that our stock solution or is that our final dilute solution? That's what we want to make. That's our final, okay? This is our final dilute solution. And then we're told we want to do that by diluting our stock solution, which has a concentration of 8 molar. So we're going to start by drawing out our final dilute solution so we can visualize it. Okay, so here we have our final diluted solution. And remember, in that final diluted solution, we have 2 liters. So guess what? There's 2 liters. Yes? What is our concentration? It is 2 molar. What does 2 molar mean? 2 molar means 2 moles per liter. In other words, 2 moles in 1 liter. So if we want to actually draw this, our 2 moles per liter, I'm actually going to divide this up so I can see my individual liters, okay? So in my top half, I have 1 liter, and in the bottom half, I have 1 liter, and I want to have 2 moles per liter. So how many dots do I have to put in each liter? 2. So how many moles do I need to make this solution? How many moles of dots do I need to make this solution here? This is not a hard question. How many dots do I need? I need 4, yes? So I need 4 moles. Now we are going to go to our stock solution, which is much more concentrated. Okay, so over on the right-hand side, we have our stock solution. That's our concentrated solution. And it is 8 molar, which means 8 moles per liter. Now this is 1 liter here, so let's draw in 8 moles. 1, 2, 3, 4, 5, 6, 7, 8. That's 8 moles in 1 liter. That's our more concentrated solution. Can you see how it's more concentrated than the final solution on the left? Now, if I needed to take some of the stock solution and put it in a container to make my final solution, how much of that stock solution would I need to use? I would need to use half a liter, because a half a liter contains 4 moles. So I would have this half liter, okay, and I would put it into an empty container. Let's say over here I have my empty container, yes, and I put in that half liter that contains the 4 moles. Now my 4 moles are in there. I know they're not in this little square, but we're imagining. And then I would add another 3 liters of water. Or sorry, I would add my half liter, I would add another 1.5 liters of water. So in total, I would have 2 liters. Does that make some kind of sense? Okay. Obviously, we are not going to do this, draw it out every time. So we're just going to do it using the math. Okay. So find the moles needed. Well, we're looking at our final diluted solution. We want 2 liters of 2 molar solution. Remember, what does 2 molar mean? 2 moles over liters. We want to find the moles, so the moles is our unknown. We have 2 liters and we have 2 moles per liter. Which of those is a conversion factor? 2 moles per liter, because it's got 2 different units we can convert between moles and liters. So that's our conversion factor. And that means that the 2 liters is our initial quantity. Our unknown is equal to the initial quantity times the conversion factor. So now we're going to have, I want to find the number of moles. That's my unknown. My initial quantity is 2 liters. I'm going to use this conversion factor up here. Okay, I'm going to use this conversion factor up here. Do I want the liters on the bottom or do I want the liters on the top? I want them on the bottom because they need to cancel with those ones. So I'm going to keep this the way it was. I'm going to keep it as 2 moles per liter, and that gives me 4 moles. Remember how up here we had 2 liters with 2 moles in every 1 liter, which gave us 4 moles altogether. That's just what we've done down here with our calculation, okay? Now we want the volume of the stock solution. Do we know anything about the stock solution? Let's go back and look at our stock solution. What do we know about it? We know its molarity. We know that it is 8 molar. Okay, so our stock solution is 8 molar. What should we do with 8 molar? We should rewrite it as 8 moles per liter. Once we've done that, then we can use it as a conversion factor. What's our unknown in this step? The liters. We want to find the volume. Okay, so our unknown is we don't know how many liters. Now, what would we use as our initial quantity here? We would go back to our previous step and say, I want to find the volume of stock solution needed to give me the 4 moles that I just found. Yes? So the 4 moles becomes the initial quantity. So I want 4 moles So what unit needs to go on the top and what unit needs to go on the bottom? Moles go on the bottom and liters go on the top. So where does the 8 go? On the bottom. And that means we have 4 times 1 divided by 8 gives us 0.5 liters, which is a half a liter, which is exactly what we found out before. Okay, now we're going to describe how to perform this dilution because this will be on Monday's quiz. Okay, and I've put all kinds of pictures in here, so should be helpful. How much of the stock solution are we going to measure out? We are going to measure out 0.5 liters. And then we get to choose a piece of equipment. So let's take a look at the equipment we could use. We could measure out the stock solution using a graduated cylinder, which come in all sorts of sizes, or we could use a volumetric pipette. The volumetric pipettes only come in 10 milliliter and 25 milliliter sizes. So if we want to measure out 0.5 liters, what do you think we should use? Should we use a graduated cylinder or a volumetric pipette? We should use a graduated cylinder because we do not have a half-liter volumetric pipette. So we are going to use a graduated cylinder. It would be handy to know how many milliliters this 0.5 liters is. how many milliliters is 0.5 liters? How many milliliters in a liter? 1,000. So how many milliliters is 0.5 liters? 500 milliliters. So we have a couple of choices for what size of graduated cylinder. 500 milliliters is a reasonable size, so we could use a 500 milliliter graduated cylinder. If you don't happen to have one of those, a 1 liter graduated cylinder would also work. Okay. This is just telling you if it's 10 or 25 mils exactly, you can use a volumetric pipette. Otherwise, you could use a graduated cylinder. All right, and here's some graduated pipettes. Don't worry about those. You can just ignore them. Now, we're going to do the transferring step. We're going to take that 0.5 liters and we're going to put it into something for dilution. Now, what we choose is going to depend on how much we need. If we have a nice round volume, and what are our nice round volumes? 5 liters, 2 liters, 1 liter, 500 mils, 250, 100, 50, 25. Those are nice round numbers. Those are things where you have a volumetric flask that comes in that size. There's no such thing as a 38 milliliter volumetric flask. They simply don't make them, right? So if you have a nice round volume, less than or equal to 5 liters, you can choose a volumetric flask. How much are we trying to make? Let's remind ourselves, how much are we trying to make? We are trying to make 2 liters. So what should we use? For 2 liters, we should use a volumetric flask. If you need to make an irregular volume, you could use a graduated cylinder. Can you please make sure that the door gets closed on the way out? Thank you so much. For irregular volumes, you can use a graduated cylinder. I don't think I'm ever going to give that to you. Like, I think I'm always going to give you like nice sizes, but you know. And then if you got something bigger than, actually that should say bigger than 5 liters, not bigger than 2 liters. Sorry about that. If you got something bigger than 5 liters, you're going to use a carboy, which is like a big jug, okay? Looks like that. And it can contain 12 liters, 10 liters, something like that. We're going to add our water to a final volume of, what was the volume we wanted to make? 2 liters. If it's a volumetric flask, you're going to stopper it, or you could use, what did we use today? We used parafilm. You could use parafilm if you want, but you can, if you're writing it out, it's nice to just say stopper. Stopper it, put a stopper in. This is a ground glass stopper. It would go in the top of the volumetric flask, okay, and you can just, okay. If you're using a graduated cylinder, it's really hard to mix in a graduated cylinder, so you would probably just transfer it to a bottle and just shake it there, okay. And with the carboy, put it into the carboy, close it, and gently shake it to mix. We're going to learn about acids next day because we don't have time today. Okay, and our homework, there's actually not that much. Okay, page 78, number 4. Dilutions number 1, number 8, dilutions 2, number 1 and 2. If you are not taking Chem 12 though, you could just be working on some of the 5.3c stuff, right, instead of the dilutions, because that's going to help you get ready for your quiz on Monday. And if you did not do so well on the quiz, I beg of you, please come in for some help, okay? I beg of you.